Hi everyone, and thank you today for joining the webinar. Today we're going to talk about modernizing application with serverless on AWS. With me today, Mike Deck, the Principal Solution Architect for AWS, and Nikody Keating, the Cloud Architect for Mutual and Enumclaw. Mike and Nikody, it's a pleasure to have you. Want to introduce yourself to us?
Absolutely, yeah. So this is Mike Deck. As Ron mentioned, I'm a Principal Solutions Architect at AWS. I work very closely with all of our partners, both ISV and consulting partners who are building new products and services on top of our serverless platform. So very excited to talk to you today about what we're seeing in this area, specifically around how customers are modernizing their applications using the serverless platform on AWS.
Thanks. And Nikody, you?
And I'm Nikody Keating. I'm the Cloud Architect for Mutual of Enumclaw. We're a mutual insurance company, and what we're doing is we're just starting our serverless journey. And by just starting, I mean we started, 9 months ago, working on serverless and like building up teams. And so my job is really to help Mutual of Enumclaw get into the AWS cloud space as well as serverless.
Perfect. So myself, I'm Ran, the CTO and co-founder at Epsagon. We're doing performance monitoring for serverless. So thank you very much for introducing yourself, guys. Mike, please go ahead and start.
Great, thanks a lot. So, just to kind of set the stage a little bit, I don't think any of these kind of statistics are probably all that surprising, but I think it's very interesting to take a look at kind of what we're seeing from customers in terms of how their businesses and their products specifically are becoming more global and digital overall. When we talk to customers across really all industries, we're seeing a lot of instances where companies find the need to reinvent their businesses and increase the amount of agility that they're able to achieve, specifically within the way that they're using technology. So we see a variety of different forces that are really driving a lot of these kind of changes. Certainly the mobile and social networks that customers are using to engage with brands and with businesses who are interfacing directly with end customers is definitely adding new interesting requirements for how businesses are able to react to changes in the market. Also, things like IoT for industrial applications and being able to automate additional pieces of physical processes and be able to integrate that kind of data into the cloud. And then also using AI and ML to then act on that data and build new interesting models and mechanisms where companies can use that to improve the products that they're building. All of these are causing a significant shift we see in the way that customers are consuming technology and the way that they are having to build their business, and really ultimately driving that need to increase the amount of agility that they're able to achieve.
Mm-hmm.
So, the way that we look at agility at Amazon and AWS specifically is we see it as really being driven by this concept of experimentation. You really have to go out and build things, get them in front of customers, and gather feedback, and then use that feedback to drive the next round of ideas and the next set of experiments that you can run. And really, the faster that you can make this flywheel spin, the faster you're going to be able to figure out what matters to your customers and be able to deliver that kind of value. So, I think a lot of times customers get stuck in this mindset that we're adopting new technologies for technology's sake, or that we just really are focused on lowering our costs or increasing our scale, or solving some specific technical problem. But when you really kind of dig down to what is the driving force that's really motivating a lot of these kinds of changes, it's really about increasing the pace at which you can run these experiments. It's about increasing your ability to gather feedback and reducing the amount of time that it takes for you to actually act on that and move forward.
I think that serverless is the great example where it allows you to increase the pace, focusing only on business and run much faster than before without all the hassles of setting up the infrastructure.
Yeah, absolutely. And I think that, one of the things that really drives that is I think this quote really kind of brings that home, is that the ability to invent really requires two things. You have to be able to try a lot of experiments, but you also have to reduce the cost of failure. You have to reduce the cost of when things don't turn out the way that you expect them to. And I think that that's one of the big things that customers who are successful with this kind of approach have in common, is that they've got a willingness to experiment, and they recognize that not every one of those experiments is going to succeed. So you really need the ability to be able to pivot quickly and deal with failed experiments as well as your successful ones. And so, there are a couple of big examples, I think, at Amazon that have been spoken about publicly in a lot of cases. Jeff Bezos talks a lot about the Fire phone that was launched several years ago that was not ultimately successful. But in light of that, in light of all of the things that we learned, we were able to kind of reincorporate a lot of that technology as well as our understanding of that business overall. And a lot of that was used then as we launched Alexa and the Echo devices. And that's one really large scale kind of example that was very public. But these types of experiments and these types of failures happen all the time, every single day at Amazon. And this is something that we really try and build into our culture and into the mechanisms that we have in place, is both the driving force to try experiments and move quickly, try something out, gather that feedback, but then also working at how can we allow ourselves that freedom and flexibility by reducing the overall cost that it takes for us to try and build something new and see if it works without necessarily having to pay a significant cost in the event that it doesn't.
Yeah.
And so this is, I think the thesis of this webinar overall is this idea that, serverless technologies are one of the core enablers of this kind of idea. This idea that you need to run experiments quickly, but you also want to reduce both the kind of activation energy, if you will, of what it takes to get started with something, as well as reduce the cost in the event that you do need to pivot and you do need to try something new.
There's one thing I might add to that as well, which is the amount of time that it takes to go from a proof of concept of something to something that can operate at scale. And to me, from a cloud experience perspective, that's really where like that serverless mindset snaps into place. Is, yes, you're able to experiment very quickly, you're able to turn around stuff, but then to go from that to at scale is fairly simple.
Yeah, absolutely. I mean, I think that's so that's really kind of what we're talking about when we talk about serverless specifically. Is a set of managed services that when you build on top of these, you're not responsible for provisioning and managing infrastructure. So in a lot of cases, historically, if you're using a traditional application model, it can be fairly straightforward to code up a little POC that maybe runs locally on your laptop. But when it comes to actually operationalizing that and turning that into something that is going to be highly available and scales well, and not only is highly available and scalable, but does so in a cost-effective manner, and you're taking care of patching your underlying operating systems and ensuring that you've got the latest security updates and all of those kind of pieces of that puzzle. That's where a lot of that friction and cost really comes in. So that's one of the first kind of key elements to serverless in general, is this idea that you no longer have to worry about provisioning and managing that infrastructure. And then similarly, looking at the scaling and high availability and security, all of that stuff is baked in. You can't turn it off. You can't make a serverless service not highly available. It's going to be spread across multiple availability zones. If there are outages, if there are failures in the hardware that are running your application, all of that's going to be managed automatically for you. So, in a lot of cases, these are things that you could automate yourself. You could build all of that automation. You could configure things so that you're deploying applications in a similar manner that make them highly available and scalable. But the amount of engineering effort and complexity that adds to your overall application is definitely one of those things that, like Nikody mentioned, it really kind of delays your time to market. It makes it more difficult and challenging to get something out there into the hands of customers in a timely fashion. And then the last kind of attribute that we often talk about when we're discussing, what does it mean for something to be serverless, is that you pay for value. So instead of paying for a bunch of servers to sit around idle most of the time, just waiting for work to do, serverless is about changing that cost model so that you're actually paying for work that gets done. You're paying for valuable things that matter to your business, and you're able to manage scale and costs in dimensions that are relevant to the workloads that you're actually trying to run, as opposed to trying to map all of that into, gigabytes of RAM and number of CPU cycles and other kind of server-based concepts.
Definitely.
So this concept of, the serverless attributes extends beyond just kind of the compute layer. And I think that this is one of the really kind of core features that we often talk to customers who, again, are interested in how do we modernize things, how do we improve our agility. One of the key kind of tenets to being successful with serverless is pick the right tool for the right job. And so at the compute layer, we've got a couple of different options, both AWS Lambda as well as AWS Fargate, for being able to run either functions or containers without having to deal with any of the underlying infrastructure. But in addition to having that kind of cloud logic layer, if you will, there are a number of other aspects of your application that you need to think about in terms of persistence. So being able to store objects or utilize various database technologies. You're also going to need to be able to manage APIs or other kind of messaging queues and other orchestration layers for your application itself. And there's a wide variety of services that all kind of exhibit these serverless characteristics that we talked about that you can easily stitch together in order to build much more complex applications and manage them in a very kind of low cost, high efficiency manner that we've been kind of talking about this whole time. So diving in a little bit more into this kind of operational model and what it is about these serverless services that really enable you to achieve that level of agility that we've been talking about. The core difference here between using this approach and a more traditional application architecture is that you're offloading a lot of the standard activities that you would typically need to do in terms of managing all of the infrastructure. Again, like we said, patching operating systems or dealing with the underlying security and virtualization layer. All of that stuff now is handed over to AWS in this case, and that frees you up to focus on the pieces of your application that actually matter. What we like to say is, customers don't buy solutions because, customers don't buy your solutions because you are extremely good at applying operating system patches. No customer, if you're selling widgets on the internet, your customers don't particularly care how great your chef scripts are. They're automating, the maintenance of your servers. What they care about is how quickly can you send them those widgets? How easy is your website to navigate? What are the features that actually matter to them? And the way that serverless works, it allows you to focus all of your time and effort and energy on creating that kind of differentiated business value and letting all of those undifferentiated heavy lifting tasks fall away to your cloud provider instead.
I gotta add actually to that you had the orchestration layer, but there is something very hidden inside of it, much bigger, the whole ability to scale. So for us, for example, handling tens of billions, almost hundreds of billions of events per month, go without moving a needle. I mean, Lambda and all the rest of the services are doing a great business for us, allowing you to ingest so much data without the effort or the operational overhead that we had without it. So it's amazing.
Yeah, absolutely. And again, I think that, the fact that, you can write an application that handles one transaction per second, you know, in a very sort of simple way. If you just encode the logic that you need for how do you handle, you know, a single message, that can then be scaled up, you know, by many orders of magnitude automatically, just by leveraging the sort of intrinsic properties of those managed services and letting them kind of do all of that heavy lifting for you.
Yeah.
And similarly, you know, and that leads well into this kind of concept as well of kind of what the overall TCO is when we talk about building these types of serverless applications. And I think that the three big kind of benefits that customers see in this space is, one, kind of reduced waste from over-provisioned resources. So this is reducing your actual AWS bill directly, because you don't have all of these servers up and running in order to handle these big spikes in traffic. So I'm sure Ron can tell you about sort of what the you know, what their traffic patterns look like, and I can guarantee you that it is not completely flat. It's probably very difficult to predict exactly, you know, when they're going to need more servers available to handle, you know, spikes in load. And with serverless, you don't have to worry about over provisioning that. You don't have to worry about paying for additional capacity just to make sure that your customers have a good experience. That's kind of all managed for you, and you end up saving a lot of cost because your utilization ends up being managed for you instead of you're having to manage it yourself. And then obviously the lower operational overhead that we've been talking about. And finally, I think really the most important piece is getting back to this ability to experiment quickly, the ability to get to market quickly. So building things that are fully, highly available, scalable, and secure, and being able to do that much more quickly than you would have otherwise, is ultimately, you know, the biggest kind of win that our customers are seeing when they're adopting these models.
Mm-hmm.
So just a couple of call outs on a few different examples that you can certainly go and search and read more about kind of what these other companies are doing. But we've got companies kind of across the board, across various different industries that are all kind of leveraging Lambda and the serverless platform in different ways to achieve various different wins for their business, whether it's reducing their overall compute costs or improving the scalability and performance of applications, or really kind of being able to improve the pace at which they're able to innovate and deploy and get to market. You know, we see this kind of happening time and time again across a number of different companies. And yeah, I'm very excited to get a little bit more insight into another company who's experiencing this right now, which is Mutual of Enumclaw, and yeah, I hear from Nikody about that.
All right. Well, with us, so I work at Mutual of Enumclaw, which is a mutual insurance company, and we've been around for 100 years, which means that, you know, along the way we've had different types of technologies that have come into our space, and compute is one of those technologies where we started off on these massive mainframe systems. And so we have a lot of our business dependent on these massive systems, which leads us to this journey that we took starting a little over 2 years ago into the serverless world. But before we go too far, so we started off in 1898 doing mutual insurance to farmers, basically, out here in Enumclaw, Washington. We started going digital in the 1970s. And back then, you know, you had these massive computers, all of them ran COBOL. And then over the time since we've done that to now, we have 35 different applications doing different types of responsibilities, all of them having to interact with each other, which when you're dealing with applications that are written in C# and Java and COBOL and, you know, you name the language, communication starts becoming one of those issues, and you start solving that issue by duplicating data all over the place. And so, you know, we've been responsible with that process, but it's one of those things where you do want to make sure that your website's responsive, that it can handle the types of load without taking in the overall cost of if you were to try to get all your information from, let's say, a mainframe from C# application. Just doesn't quite work. So I'm going to take you through an overly simplified view of kind of new business coming into Mutual Enumclaw. So new business comes in. We work with independent agents. So independent agents are able to go out, find customers, and represent those customers and their specific needs. They come to us and they say, all right, we have some new business. So the first thing that we're going to do is we're going to get some pricing for them, what we call rating. And after rating it, the agent is able to work with the customer, say, is this really, you know, a price that you're willing to pay for the services that you're going to get? After they say yes, we go through, we make sure that all the rates match up. We generate documents. We go through integration so that the rest of our systems can know that this is a new customer of ours. Those integrations do some processing, and at the end of that time period, everything's ready to go. So the world as we knew it, you'd have data come in, it just gets stacked up, and then from there it would start processing one at a time, and that jumped forward really fast. But it'd come in, process one at a time, then the next one would come up, and then the next one, and that works really great until it doesn't. And you have one policy in that system hit that roadblock of, this isn't something we expected, and suddenly you're in the 3 a.m. wake-up call time period, because we can't do this processing during the day, since it takes up a lot of CPU and a lot of processing power. We have to do it in the middle of the night. So now our developers are being woken up at 3 a.m. and developers are an interesting breed. We like to go to bed late oftentimes. We're not really morning people. And so you get this groggy developer trying to figure out what happened with the system that caused it to break, get that thing fixed so that it can continue processing, and then hoping that the next day the same thing doesn't happen again. So we started looking into, as a company, how are we going to move forward? And we made the decision that we're going to go into AWS as our cloud provider. And we wanted to go into the cloud. We knew that. So we put together some principles that we could use moving forward to help us with our decision-making in a responsible and predictive manner. And so our first one is exercise discipline to automate, simplify, and evolve. That means creating everything so that we don't have to have hands-on people to do every single little modifications to systems or to monitor. And then we start off simple, and then we evolve it over time to as we run into more complex issues. The next principle is strongly prefer AWS native solutions. There's something to be said about making sure you're not tied into a single provider. But one of the things that we quickly came to the realization is that if we went in and really leveraged AWS native solutions, we could move faster and we could move cheaper, because we're able to tie into like those integrations that they already have and put less work into trying to make it generic. The next one is teach what you've done. So as a culture, we really believe in, when you learn something, you should teach somebody else what you've learned. And that's going to elevate everybody in what they're able to build. The fourth one, evaluate AWS expertise in the decision-making process. So we work really hard to educate everybody in Mutual Enumclaw on the IT side as to AWS and what its capabilities are. And those people who gain expertise in AWS get brought into more decision-making around AWS itself. And then emphasize transparency, collaboration, knowledge sharing, and broad team engagement. And that really speaks to, we don't want to operate in silos. We want the people who are doing the work to be the decision makers. So we started off with AWS, and we went into immersion days, which was great. We got to learn a lot about AWS, a lot about the capabilities, and it was like a fire hose being aimed at us in terms of the amount of information we were taking on. we then were like, all right, let's send people to reInvent. So we took, developers, system administrators, network administrators. We took directors. We took our CIO, and everybody went to reInvent, except for one person who had vacation issues. They were going to Hawaii, and that was me. I'm not going to cancel my trip to Hawaii for reInvent. So they turned to me and were like, okay, well, we want you to do something cloud. So go out and find something. And I was like, okay. And I went out and, was searching around and found Serverless Conf. I'm going to go to Serverless Conf. And everybody was like, what's Serverless Conf? So I went off to Serverless Conf. Everybody else went to reInvent. And so we started dipping our toes in the water of this whole serverless technology. And after going through Serverless Conf, I kind of got a sense that this was kind of something. It wasn't really tangible. I wanted to get some hands-on experience with it, but it was definitely something. And so what I did was I worked with my team, and we made a systems that would allow our independent agents to communicate with our underwriters via email, which is kind of that preferred method of communication. But then we put in a serverless solution to take those emails and index them as part of the record for the quote or policy, which suddenly made it possible for the agent and underwriter, rather than logging into our system, to just be able to email back and forth pretty freely, and then still have that system of record. And so what we built was we hooked up our email server to communicate with API gateway. That would trigger a Lambda function that would look at that email and see if we had enough information to actually process it. If we did, we'd just put it into an S3 bucket, which would then add to an SQS queue. The SQS queue is probably one of the really cool things that we found in AWS's ecosystem, because it allowed us to make sure that we processed everything and not miss anything. And if something wasn't processed correctly, it'd just stay there and wait to be processed again. So from there, a Lambda function would trigger off of that, and that Lambda function would be injected into our VPC so that we could have a direct line of communication between that and the SQL server that we used for on-premises for our web application. So that was pretty cool. And this was the first time that we were able to turn to our executives and say, all right, well, we can build the solution, and we built the solution, and what it's going to cost you is $6 a year. Up until that point, putting a price tag on a new capability was kind of one of those intangibles, right? You build up features all the time, but the ROI for a feature going into a web application that's a monolith is, well, we just added this thing in there, and it's going to have to scale and stuff, but we really don't know what that's going to cost. So suddenly we were able to tie a piece of capability to how much it was going to cost, and be able to have visibility into how that particular system was operating independent of the rest of our system, which was really, really cool. Well, that was interesting. So we kind of maintained that for 6 months, and we were kind of trying to figure out, what do we want to do next? This serverless thing seems really cool, but, how should we proceed forward? Let's do Serverless Conf again. So this time we sat back and said, okay, well, this thing seems, bigger than a bread box. I think this could really be a thing. So this time we picked out 2 developers, a director, and myself, the cloud architect, and sent us all to Serverless Conf again. And it was kind of crazy, because over the course of a year, Serverless Conf had grown. There was more people involved. We got to, see talks from people like the people who do iRobot. We got introduced to the serverless framework. Firebase had some really cool stuff that's coming out. AWS had AppSync that came out, and the ecosystem around serverless was growing. And then we also ran into Epsagon, and we saw Epsagon, and then or I saw Epsagon, I should say, and I had to drag the rest of my team over to see what they were doing because before going to Serverless Conf, we were trying to figure out how to track messages between all of our different services.
It was love at first.
And so, oh yeah, absolutely. so, you know, having a different level of visibility and having people out there working on that was really cool. The other thing that we ran into was Cory Quinn, who gave a talk down there. And Cory Quinn is a comedian that gives a snarky, or has a snarky blog on all the latest things AWS is related. He is hilarious. If you ever get a chance, go out and check out his Observerless talk. It was mind-blowing and life-changing for many people here at Mutual Enumclaw. So anyway, we did that. And while we were there, the developers were actually opening up their laptops, trying to do serverless stuff, or just starting to do serverless stuff. The director and myself were trying to figure out, all right, how do we do something with all this cool stuff that we're seeing and learning? And so we came back and we worked with the CIO here at Mutual Enumclaw, and we decided, you know what, we can't do something small. It has to be big. And, you know, as we tackle this big thing, let's have our goal really to learn something, right? So if we have a lot of people that come together, try to do something big but not succeed, at least they'll learn something and they can take that learning back to their team. And in that process, let's pull some of the great developers we have off of all of our different teams. We're going to just manage expectations for a short period of time, saying, you know, well, we're going to do some training. Let's just adjust the number of features going out the door. And, you know, when they're done, they can all go back and teach everybody else all this really cool serverless stuff. And let's see what happens if we give them 4 weeks to replace all of this, all of our mainframes. So we're going to give them 4 weeks, go make something. You're going to replace all of that. And then, you know, well, training, probably should figure out something around training. So we'll add some time for training too. So let's see what happens if we give them 1 week of training and 4 weeks to replace all of this. So we started coming up with a real-time vision of what life would look like when we moved away from our mainframes to something that'd be a little bit more real-time. And what we quickly saw is that instead of dealing with having something where you have processing going on in the middle of the night, we could move to real time where processing happens as soon as somebody clicks the button saying, yes, I want this. And what that really does is it changes the time frame where developers are supporting the customers. So you move from everything being processed at night to everything being processed during the day for the most part when the developers are in the office. The other thing that happens is by having a real-time system, when one thing fails, everything else keeps moving. So instead of having to have this fire drill around, we have tons of business stacked up that we can't process, now we're down to, hey, a customer had an issue. Let's fix that one issue and move on. Mm-hmm. The other thing that we wanted to do is we wanted to reduce the amount of maintenance and increase the capabilities and the speed to market. One of the things that I mentioned earlier is that we have a lot of databases with duplicate content. And with the serverless technologies out there like AppSync and so forth, it really allows us to start taking a look at and say, let's use a common set of technologies that will centralize our data hub and make it so that all of our other applications can operate through APIs to get access to this data. So they can operate independently, but on the same source of data that we're doing operations like batch processing or renewals on. The systems that we were doing batch processing, I should say. But the same systems that are doing the renewals, that are handling underwriters going in, making adjustments, making sure that our book of business is healthy. So after 4+1 weeks, we'd actually done a lot. We built the basic components of a system which could replace a new policy system, and new policy systems can run tens of millions of dollars. So high investment, and we were able to do a lot of those basic components in serverless in 4 weeks. We demonstrated the value of a real-time system, which really means that everything speeds up, including the way that we think about how we do business. And it's kind of impressive when you start speeding everything up, the options you open up to the rest of your business to say, hey, do we really need to operate this way? Could we change our processes and change what we provide customers based off of real-time capabilities? We had a way to automate the renewal process, which a renewal process is really, you have a policy that comes in and you have to go out close to a year out and have something trigger a year out to tell you, hey, this particular policy needs to be renewed. And we actually were able to do that using DynamoDB time to live, which allowed us to really forget about, trying to scale databases, trying to think about, do we have to look and pull for information as to which policies need to be reviewed? Now we had a system where it would notify us when something needed to be reviewed. And then the other thing that we were able to put together is kind of one of these newer trends, which is we could have people on different web browsers collaborate real time with each other on the same policies, which, like, if you think about, like, have you ever had issues with, your system and called up help desk or called up somebody to help you out? If they were actually able to operate on the same exact piece of information that you were having a problem with, that's something that allows you to move past that much more quickly. So we do all of that, and our developers all sit down for a feedback session, and the first response was, can we get 4 more weeks to see what we can do, which was awesome. This tech is amazing was another common one. And then, if you stick me back on my team, or you can stick me back on my team, but we're going to start doing this anyway. So, like, the developers were really excited, really bought it. And so we continued this process, and we continued building the system out, but we also had to take a step back. What we'd originally built was a fairly complex system. We had SQS queues, we had Lambdas, we had DynamoDB, we had Firestore, we had Cognito, we had rating systems all working together. And one of the things that we found was this can get really complex as you build out. And so Firestore was a great little getting our toes in the water of real-time collaboration. But did we really need that? Because one of the things we also ran into was this infinite loop that we created between Firestore and DynamoDB, where you'd have a policy come into Firestore, trigger a Google function that would call an SNS topic that would get queued up, that would then be processed by another Lambda function that go into Dynamo. That Dynamo record would then be processed for rating, so we get some pricing done, and that information would be stuck back in Dynamo, which would then go all the way back down to Firestore. Firestore would then see that a change had occurred, and then trigger the Google function. And so you just end up with an infinite loop. We found this because we started getting errors from DynamoDB saying that we'd exceeded our write throughput. And so that was kind of one of those, we might have built something a little bit too complex. And so we started questioning all those assumptions. And, we also started identifying what was it that we really wanted to do with this thing, because now it's starting to become real. And that was basically after 4 weeks, we started saying, this thing looks like it could be real. So eight weeks in, we started forming the team. And so we pulled in business analysts. We pulled in a product owner. We adjusted the team based off of external needs, because now we're no longer talking about, we're going to manage expectations for a short period of time. We're talking about, hey, this is going to be an actual team that's going to have its own backlog of work. We chose goals for the team. So we chose an existing state that we were in, and we chose a complex line of business. And part of that was it allow us to already have all the knowledge as to what was needed already available to us. So we didn't have to go out and do a lot of research. The second thing that it allowed us to do is it allows us to run this system side by side by our mainframes to prove out that this new policy system handle anything that the mainframe could do and do better. So we also started asking ourselves, how do we want to support this thing as it grows? We already ran into the problem of we made a really complex system the first time around, and we'd really like to make it so that this system was easy. And so, you know, one of the things that we want to do is, you know, we'd love to make it open source, and that's what we're working towards. And is there an example of an open source platform that we like? And the most prevalent open source platform out there that has kind of exceeded expectations across the board is WordPress. And the reason why I say it's exceeded expectations is because, you know, practically half the internet runs on it. But what it allows you to do is it allows you to plug into any place in their process that they have in WordPress and inject your own code or replace portions of WordPress with your own logic. And they make it really simple to do that. So we started taking a look at that and said, okay, well, we've gotten to this critical mass place. You know, the system's complex. Not all policies and processes are made the same. And, you know, that makes it even harder because, you know, we're going to have to make these one-offs, or we're going to have to add in complexity to the system. And then how do we handle up to 50 states worth of data as we grow as a company? And so as we were thinking through that, we were like, wow, this is a really complex problem. Wouldn't it be nice? I mean, we know the general workflow of what processing looks like. We know how things kind of should operate, but the specifics can change based off of a lot of different variations in terms of policy types and states. So what if we had a workflow where we could define the workflow up front? And we could say, okay, well, this is our general workflow and how we process policies. And then afterwards, we could plug in. And this is where we've come up with what we're calling the orchestrator design pattern. And so you have a workflow. That workflow takes in some metadata, and then it has activities. Those activities, such as rating or verification or document generation, then have places for plugins to plug into before, process in parallel, or do some like parallel processing with other functions that are doing stuff at the same time, and then it has the place to plug in after. And this allows us to have kind of that WordPressy type experience where you can develop a small little unit and plug into any part of a workflow without having to change the overall architecture of the system, or without having to know the details of how the system interacts in various processing workflows. Mm-hmm. And so you have the sequential before, which makes it very predictive. You have the parallel that goes on all at the same time, and we're able to use SNS filters to say, hey, this particular plugin only wants to handle auto policies, or this particular plugin only wants to handle package type policies, or this plugin wants to only handle policies that are for Washington State, for example. And then you have the after that runs as well. And so the orchestrator, or with the orchestrator design pattern, you know, we can really do that date-driven activation. So it also helps us with, we have functionality that we want to have come online on a specific date, right? And then other functionality that we need to remove at that same date. So we can suddenly do date-driven activations and deactivations, which simplifies our world dramatically because we no longer have to try to figure out how to activate or deactivate a feature one at a time. We can do location filtering, we can do feature filtering. And as we are looking at this, it really just simplifies the way that we think about processing policies to the point where you don't have to be an expert in AWS to work in the orchestrator design pattern because you're just plugging into a workflow and you're only handling the information that you care about. So where our journey has led us is we're using AppSync. We have our data hub. We have our renewal core. That core is going to be using the orchestrator workflow process. And then we've broken apart our plugins into what we're calling public, which is the stuff that could be open sourced and easily shared. Protected, which is there's different companies that in order for you to get access to information on their APIs, you have to have a deal in place with them. So we see this place where we're going to have a set of pre-built capabilities that we can't just openly share, but if somebody already has a deal in place with this other company, they can have the code as well. And then we have our proprietary private stuff, which is how we hook into our existing systems back here at Mutual Enumclaw. And so we have the issue core, we have endorsements, orchestrator workflow system, and all of it's built on this concept of let's make everything, all these capabilities, just plugins into our system. Our vision for the future is we're going to decrease the number of full stack systems. So as I was talking before, we're using AppSync. That really allows us to have pivots on that information so that we do thin front ends that collect information and then provide that information to the customers. But the back-end systems are the systems that are doing the processing because we have that ability to scale incredibly high. The second is we're finding that we can increase the amount of effort we're putting into monitoring notifications. Tools like Epsagon allows us to have that visibility where, let's say a customer comes in or an agent or an underwriter comes in and they run into an issue. And inside the team, and even, we'd like to get it to the point where even our help desk team has this visibility to say, oh, it's this underwriter that logged in. And let me pull up what they've done recently. And I can see every microservice along the way that was triggered based off of that change they made. And track that down to where they're having the issue so that I on the help desk could help them get past it. And I as a developer get notified before they even know that they had an issue. And suddenly we're changing and we're fixing things at a much faster rate because we're not dependent on our end users to notify us that they had an issue, which means that you don't have to have all of that people process in the middle between your customers having an issue and it making its way all the way to the developers. And then we're going to, as we do that, increase the amount of time that we're spending on new capabilities. So as we're moving along and we take a look at rating, we're finding ways to move the logic of the rating to systems like there's a system called DRC, which takes in spreadsheets and turns out C# web services. And the spreadsheets can actually be managed by our products team, who used to have to rely on developers and our processes to get new rates and new rating changes and other things hooked into our system. So we're empowering our other departments to work independently from our IT group, which means our IT group starts focusing on more new things rather than trying to maintain and keep the lights on. So what we've learned is, we're excited about serverless technology. It's removing a lot of the barriers and processes that we used to have in place due to the number of people being involved in maintaining the application. We're simplifying our data storage with NoSQL. So instead of trying to think through how do we store data, how do we make these relational data tables, how do we make it so that our queries come back fast, we're thinking about how do we structure our data and create our data models in a meaningful way to us, and then leverage the capabilities of NoSQL to store that data structure and retrieve it back quickly, which just increases the rate at which we can innovate. Every so often we run into an issue where we catch ourselves talking relational still, even though we're dealing with NoSQL, and we have to catch ourselves and ask, ourselves, is this the right thing in this new technology paradigm? But those sorts of challenges are kind of a nice place to be, because you're really trying to shed the preconceptions that you used to have about how much it took to develop a piece of capability. Mm-hmm. And then we're transitioning to a real-time system and business model. So we're starting to look at what's the tangible business value. What progress or processes can we move due to the way that we used to work? And then how can we increase what we can offer to our members and agents based off of these real-time capabilities and these serverless capabilities, which means that we are putting more and more time into making lives better. And then finally, we learned that this is really cool and addicting stuff. Like, you get your toes into serverless and you just kind of want to be there more and more.
That's definitely addicting, Nikody. I really love your example. I mean, you're talking about serverless as the broader term of, all the resources and everything that you built on your own. And actually, I think one of the things that you've mentioned, like moving fast, and also Mike mentioned, I think it's a bit thanks to the fact that everything is managed for you, but also to the fact that you can gain confidence with what's being deployed. Or in general, mainly talking about transformation, where you had like an old AS400 or an old mainframe application, and you're now moving to serverless, which is a big change in the mindset. So getting, confidence with what you're building, that it's working, and you get the right input and outputs from your orchestrator for each and every function. It's really crucial for success. In general, what I'm going to talk about, it's mainly observability, or a great platform that gives you the visibility that you need for your applications. So we already talked why serverless is great. I'll just review that very quickly. For me, I think the main one is the auto scaling. I mean, it reduces the friction, very big for us, and also the pay-per-use. You can see an example of like a regular or normal server utilization, where most of the time it's being idle. So the ability to scale down to zero with most of the services that AWS offer under the serverless platform is great, can reduce a lot of costs. The operation that is being changed, and honestly, it all comes down to the focusing on the business logic and iterate much faster. Now in serverless, we can see some other limitations, or specifically in function as a service, some other limitations that are coming up. I think that the most notable one is that we got limited running time and limited memory. So it's not necessarily for bad, but it means that now our code need to run up to a certain amount of time and use no more than a certain amount of memory. Otherwise it will break. It can be broken in dev or production. We need to make sure we know and we're aware of it, or if it comes closer, to take care for it before it happens. Now, also serverless applications are more stateless, or they are stateless inherently. It means that you need to interact with some APIs to do something, to do some calculations, to return some interesting value. And these things means that the application are a bit different. They are more IO bound, and you need to make some more communication to the outside world. Now, there are cold starts. I'm not going to elaborate on that, but just effects of might affect your performance, and you need to make sure you know or you're aware about it. Also the concurrence limit, but it's a pretty soft limit that can be increased. Now, I wanted to give another example for a simple application that built on top of serverless. I actually did this one as a store, a catalog store. And you can see that even a simple use case of a store becomes highly distributed, and everything turned to be event-driven, including resources such as API Gateway, AWS Lambda, the amazing DynamoDB that you mentioned, Nikody, NoSQL. It's a real big change in the mindset, but once you go NoSQL, you almost can't go back to SQL. And you're also using on top of that some other APIs like Stripe, Twilio, Algolia, Slack, Redis, and so on. All these are building together your full application. And I think once you understand that you want to monitor your application, which is your business, it's not only the Lambda function, it's looking at the whole picture and understanding and gaining confidence with what you're having in your production. Now,
and one of the things that that we discovered when using Epsagon was our Lambda functions, when they're making calls to APIs that were on premises here at Mutual of Enumclaw, Epsagon actually captured that information as well. So we actually had the map from our serverless world all the way to our on-prem world, which was amazing.
Yeah, I mean, the fact that out of the box, you know everything that happens, I know it's invaluable. So there are some new monitoring challenges that come when you're going fully serverless or fully managed. So first is that you got no underlying access to the infrastructure, either for your function as a service or for your SNS, S3 bucket, API gateway. Those are encapsulated services that work great, but all of a sudden when you got a problem and you want to investigate more, you can't access it. Also, it's ephemeral, so it means that after it handles your request, there is nothing left to troubleshoot there. Also, everything becomes more and more event-driven. So, you know, you need to be aware of what events are being sent from one service to another. It can be even from a third party or any service in your system that is moving messages in an HTTP or message queue and so on. So you got to be aware of what's going on. Also, I think that this is actually a huge benefit, but you just need to make sure you monitor that. Since in serverless, you can actually break down your business into some transactions or business flows, it really is up the way for you to calculate how much a customer costs you or a service costs you. But it's also a bit hard because cost calculation requires some more understanding for that. So you can't go and say, okay, it costs 3 servers and 2 databases. It's more about every single transaction in it. And also, as we saw before, that everything is ephemeral and we've got some new limitations that we need to be aware of. Now, the way we look at Epsagon for observability, it's a bit different than everyone. So we start with the base compute unit, which is the function or function as a service. In our case, is the AWS Lambda. So you need to start monitor at this level, obviously, but this is where most of the other solutions are stopped, and this is only where we start. On top of function, we offer a way to look at the transaction. So transaction is a list of traces that are related to each other in an asynchronous manner or even synchronous manner. It means that they are related to each other because it's a message that went through an SNS or an SQS. It's a file that was put to an S3 bucket, or maybe a record in a Kinesis or an HTTP GET request. So it can be all connected together, and you want to see them stitched together rather than every resource individually. On top of that, there are transactions that are repetitive for your business. Hence, you want to look more about the business flow rather than every single transaction. So transaction can be when a new policy is being processed, and you want to make sure how does the business of policy processing looks in overall for the last week, how long it takes, how many errors there are, and so on. Last but not least, as every application got its own architecture with all of the resources, and sometimes you just want to make sure the architecture plays well, everything, and there is any issue or any degradation in performance in one of your resources. Either it's the function or even like let's say DynamoDB or SNS or API gateway and so on. Let's try to review some of these elements quickly. So we'll start first with the functions. So this is the core compute unit. It's great for detecting errors and performance issues, mainly related for serverless specific issues, the one that we talked about with timeouts and out of memories. And this is a great example from Epsagon, from the demo environment, where you can see all of your functions, how much traffic do they get, how much of it is any kind of error, and also track the cost. So for me, honestly, we hit a lot of time issues where performance impacted our cost, and the two are relying on each other, and monitoring the cost as well helped us to improve the performance drastically and reduce our AWS bill, which is great. Now, this is the base compute unit. The second one is the transactions. So transactions can provide context and correlate different events. In this actual example, we can see an API gateway triggers a Lambda. Then this Lambda calls off to 0 for authentication and publish a message to a next SNS, which triggers the second Lambda. Now, when you've got a problem on the second Lambda, sometimes it's not enough to just look at the logs or just read the traceback. Sometimes you want to go back and understand what message went through this SNS, what was the originator that published that message to the SNS, and what he did before that. So seeing everything in a transaction view is really great for troubleshooting application level errors from one end to another. Now, on top of that, I mentioned that sometimes you want to look more about the business flows rather than every single transaction. So when aggregating transactions all together can give you a great visibility to your business KPIs. For example, how many times per week do I process a new policy? Or what is the, for example, how long it takes for a policy from one end to another to take place, or how many errors there are in a certain amount of time. This allows me to make sure that I'm standing with my business SLAs. Now, last but not least comes the architecture. Honestly, first, it's cool to see everything visualized automatically for you, including all of the resources, all of your APIs, even internal ones, external ones. It's really great. And here you can actually track each and every resource performance, errors, SLAs, and so on. So it's great just to making sure and gaining confidence with what's going on in your production. Just behind the scene, I want
to add to that, a little bit, from my perspective, being a cloud architect, as my development teams are increasing in terms of how fast they're moving, having that visibility to everything and how it all is working together is extremely important. And having it done automatically for me, where I don't have to go out and try to collect that information, I can actually see what's happening live in production, is huge.
Mm-hmm. I totally agree with that. Like the ability to gain confidence and let the team run much faster. Now, I wanted to share also a bit about the Epsagon's technology behind the scenes. So we start with automated instrumentation. And I think when you've said that you're seeing everything automatically, this is the key thing for a winning product, because when you're using a managed service, you want it to come out of the box with everything automated for you, rather than you need to configure it and manually add code or segmentize or configure anything. And the fact that once you're importing or requiring Epsagon to your code, you need to do zero code changes from there. It automatically captures any API that you're using, any AWS SDK resources that you're interacting with. And of course, we make sure that we don't impact the performance of the original Lambda function, because obviously we don't want to do it, and it's under 5 milliseconds. The second thing is the automated distributed tracing. So seeing it every trace individually can be hard sometimes, especially on the example on the right-hand side, where a Lambda publish a message to an SNS and it triggers another Lambda, rather than seeing 2 different logs or maybe 3 different metrics all of a sudden. You want to see like a real transaction from all the way from the start to the end, and understand how long it takes from end to end, what are the messages that are running from one end to another. It makes it easier, much more easier to understand the root cause analysis, for example. On top of that, we provide business flows analysis, so making sure repetitive transactions are being visible and you can focus on what your business is doing, where your business is your application. We provide the visual debugging as the transactions that we saw before, and some cost tracking just to make sure that you're on top of everything. I think that the last thing that I would like to cover before going out is when is the best time to look for a monitoring or observability solution. So I think that what Nikody done with Mutual is great, because when you start with a project and you understand that you're going to put your effort in serverless, you definitely need such a monitoring solution, because you can't go into production without making sure your business runs properly. But anyways, if you're already in business, definitely if you find out yourself with tons of logs, that doesn't help you to investigate an issue, mainly because there is no context to logs, and there are logs now from lots of Lambda functions and other AWS resources, which can be great, but when you need to correlate between them, it's just, there's no context to one another. Also, when you have too many moving pieces in production, so it means that it's not only 1 or 2 Lambda functions, but when you're having, like Nikody's example, tens of Lambda functions and lots of other resources, everything is interacting with one another, it's really hard to keep track with what's going on. Also, when you want to make sure that you're aware of the serverless specific issues, like the timeouts and out of memories and the cost that we talk about, it's really important to have such a tool.
And to add to that, one of the serverless unique issues that I've run into is what we've coined as runaway serverless functions. And that's where you have something sitting in an SQS queue and a Lambda is triggering off of that and processing that message, but failing. And then another thing is being added, and both of those are failing. And then another thing's added, and you just have these functions that just kind of start running away. And how we found this out was originally, when we first found this out, was we got a call from Epsagon saying that we've used up the majority of our usage for our particular plan that we were on. And we're sitting here going, we have 4 developers and a cloud architect and a couple BAs. There's no way we're using that much. And it turned out that one of our functions got stuck. It had a bug in it. And so it, in the course of 11 days, was invoked 260,000 times. That function called another function that was also invoked 260,000 times. And so that was over the course of 11 days. And so having that extreme flexibility and that extreme ability to handle large scale also means that having awareness of things like runaway functions is really key, because you don't really know what's going on like you would on a server where you're actually monitoring CPU one at a time. And it's really easy for runaway functions to occur.
Yeah, I usually say that with great scalings come great responsibility. So you just need to make sure you're not too overscaling and making sure your application works according to what you're expecting. And to that, I would love to add the last thing, which is obviously track your business KPIs and cost, which in serverless, we mostly talk about what our business is doing. So here it's a great example why you need such a monitoring solution. Well, first, I want to thank you, everyone, for joining in to our webinar. Thank you very much, Mike. Thank you very much, Nikody. If you have anything to add to the summary, Mike or Nikody?
I don't think so. I think we covered a lot, and I think this, again, mutual example is a fantastic kind of case study in how companies are adopting serverless, starting small, starting off with that simple sort of email use case, and then continuing to look for new opportunities and scaling up and educating their developer base, and then adding in the appropriate tools to make sure that they're successful. So yeah, really enjoyed hearing about that, Nikody. So thanks a lot for sharing.
Any final words from you, Nikody?
No, this was great. No, like the only thing I'd stress to people thinking about getting into serverless is get rid of preconceived notions on making monolithic applications and think about how you can do just small pieces of capabilities. And it's amazing what you can learn about your system and about what your customers are doing when you've separated your functionality into different Lambda functions and are able to monitor those, identify how much a particular capability is being used. And it just limits what you have to put in and the amount of effort you have to put in.
Yeah, I totally agree to that. So perfect. Thank you very much all for joining. If you're looking, you can ping any one of us or DM us on Twitter. We'll post some details afterwards how you can reach us. Thank you very much for joining.